Hi guys, tonight we're going to take a look at how to graph the line of best fit on the Ti-84 calculator. Or I have a Ti-83, but Ti-84 would work well. So you're going to need your calculator for this. If you don't have a calculator and you're on a PC, you can go to my website, and in the middle on the left there is a pink tile that tells you how to download this version right here onto your PC. So let's go ahead and get started. So we have calculated the line of best fit or the trend line for a set of data or a scatter plot by using three methods so far: the eyeball method, the X mean Y mean method, and the Q points method. And the eyeball method by far is the least accurate, and of the ones that we've done so far, the Q point method was the most accurate. So we're going to take it a step further. We're going to use the calculator, which is the most accurate out of all four methods, to find the equation for the line of best fit. So first thing we're going to do is go ahead and clear our calculator. We do second plus 7, 1, 2, and we've done this before. We're going to do second plus 7, 1, 2, and that clears anything that's in our list. It clears off our stat plots. It clears everything out of there. So we're going to graph this set of data right here, our X and our Y. And we've done this before when we did the pumpkin a few weeks back. So to find our list, to input the X and the Y coordinates, we're going to create a list. We're going to hit the Stat button. And the Stat button is right here. And what's going to come up, it says Edit, Calc, and Test. Looks just like this window over here. And we're going to go ahead and hit Enter. And we are going to enter our X values in list 1 and our Y values in list 2. And we have to hit enter after each entry. So 2 and then enter. That way it's recording the data that we've put in there. If we don't hit enter, it won't move on to the next one. And when we did the pumpkin, we did quite a long list. This one is not nearly as long. So I finished my list 1 data. Now I want to arrow over and enter my Y values in list 2. And again, I want to hit enter after each entry. And I want to make sure that I have the same number of values, entries in my X list and my Y list, because if not, my calculator is going to say you did something wrong. And our last number is 10. And so if I look at this, I have 8 items in this list and 8 items in this list. So we're done with that list. So I'm just going to arrow down here a little bit. Bring my calculator back up again. So we want to set up our scatter plot. So I'm going to move this over here. And to do that, we have to turn our plot on, because if I hit graph now, nothing shows up. So I need to hit second and Y equals, and that's stat plot, which are these little words up here. And that's going to show me the 4 plots, and you may have more. And they're all off at this point. So I want to turn this plot on so I can graph all that data I just put in list 1 and list 2. List 1 and list 2. So I'm going to hit enter, and I'm going to hit enter twice. So now the cursor is flashing on the word on, so I turn my stat plot on. It's on a scatter plot. My X list is L1, my Y list is L2, and the mark that I'm going to use on my graph is this. So now if I hit graph, I can see part of my scatter plot, but I can't see the whole thing. So this is where I want to see my scatter plot. So we're going to hit zoom and 9, and that really is called zoom stat. The zoom button is right here. And then we want to hit 9, and that's going to zoom in on our data. So there's all the data points that we entered, our X and Y list, our list 1, and our list 2. So if we look at this data, what kind of correlation does it have? It's going uphill, so that means it has to have a positive correlation. So now we want the calculator, we want to use the calculator so that we can find the equation for the line of best fit, because it's going to be kind of hard trying to find the rise and the run and trying to find out what data points these are by looking at a calculator screen. So let's take a jump down to number 4. The calculator will also tell us the correlation coefficient, and we talked about that a while back in a couple of the notes. And the correlation coefficient, or the R value, tells us if it is a strong positive correlation or a strong negative. And if it's close to +1, that's going to be a strong positive correlation. And if it's close to -1, that's going to be a strong negative correlation. So my calculator just turned off. I'm going to turn it back on. So in order for the calculator to do that, to give us an R value, we have to turn it on. So I need to hit second and then 0. And this is my catalog, and a bunch of different things in here, absolute value. I could turn the axes off, but I'm looking for the words that say diagnostics on. And that's right there. So I want to hit enter twice until it says done. So now my diagnostics are on. So when I go to find my equation for the line of best fit, it's going to give me an R value. So now I want the calculator to take all this data that we've entered in here and find the equation, find the slope, find the y-intercept, and give us an equation for the line of best fit. So we're going to hit the stat button again, but this time we're going to arrow over to calc. And all these wonderful things come up. So we want to call it, it's number 4, it's called a linear regression. It's a line of best fit, it's slope-intercept form. And it says AX plus B. The calculator uses A for slope instead of M, but X is still our input and B is still our y-intercept. So we want to arrow down to 4 and hit enter. And at this point you want to hit enter, depending on the calculator you have, at least 3 or 4 times until this shows up. My calculator is old, so I only had to hit it once. This is our linear equation, y equals mx plus b, and again the calculator uses A instead of M. So the slope is 1.8. The y-intercept is 0.65, and the R value is 0.99. So as we said over here, if the R value is really close to 1, and it's a +1 in this case, and actually rounds to +1, this is going to have a strong positive correlation. So if we round our numbers, the equation for the line is right here. It's approximately 1.8x plus 0.65. But I want to get this equation on this scatter plot. So how do I get it to look like this? So this is in y equals form. So this, we're going to do number 6. We're going to go to y equals, and we're just going to enter that equation, 1.8x plus 0.65. And if you just put plain old 0.65, that's fine. Now when we hit graph, there's our line of best fit right there. Is that beautiful or what? So we can also see our data points that were all plotted on there. So what's that information going to do for us? Whoops, sorry about that, went down too far. So now we can use our table of values to look at the inputs and the outputs for this line of best fit. And again, we use a line of best fit to make predictions. So we're going to go to second in graph. So second in graph, and if you look up here, these tiny words say table. So that's going to give us all our input and all our output values for this equation right here. If we arrow up, we can see negative inputs for x. If we arrow down, we can see some more positive inputs for x. And all our inputs are integers. And this table is counting by increments of 1. So what if we wanted to see what our y value would be if x is 25? Well, we can either arrow down to 25 or even 45, or we can go to window and table set. So if I hit window, second in window, this is what comes up. And my table right now is starting at 10. If I want my x values to start at 45, I just hit 45 and enter. And this tells me that my table is counting by ones. So now when I hit second in graph, it automatically starts at 45. If I go to second in table set again, let's put that number back to, let's say we want that number to be 100. And again, I don't want to arrow down to 100, but I want my table to count by 5s. That's what my x values are going to count by. So now when I go to second in graph, it starts at 100 and I'm counting by 5s. And I can even make those numbers smaller. So let's go back to 0. I can even make my increments count by halves, by 0.5. So if I go to second and graph, all my x values are counting by 0.5, so we can find decimal values as well. So let's go back to our graph right here. There's our graph for our scatter plot where we entered the data right here in the lists. We used the linear regression to find the equation for the line of best fit. We plugged it into y equals, and now we have the equation for the line of best fit and the line of best fit on our scatter plot. Okay, so your homework for tonight, or part of your homework for tonight, is to take a look at these video questions right here. So you're going to use your calculator. Make this a little smaller. Oops, sorry, smaller so we can see it. So you're going to use your calculator to enter this data into your X list and your Y list, list 1 and list 2. The low and high temperatures for week 1 in Poughkeepsie, New York are given below. This is our list 1, our X values. This is our list 2 and our Y values. You're going to use that data, plug it in your calculator, use the steps on the sheet that we just went over, and write the equation for the line of best fit in the form of y equals mx plus b. Then you're going to use, also, since we've already turned diagnostics on, you're going to use this table above, and you're going to state the correlation coefficient, which is R. So what's the equation for the line of best fit? And what's our correlation coefficient? And again, once your diagnostics are turned on, unless you reset your calculator, the diagnostics will continue to be on. Please make sure you enter your answers into the Google form, and we will practice this with more with this in class on Monday. Have a good weekend.